And good evening instead of good morning. This is going to be a little bit of an off-brand live stream. It was not really very well planned. Yes. So after Sunday's live stream where I didn't finish assembling that board, I thought, well, maybe I was intending to just go on and finish it after the live stream. And then I thought, well, if I'm going to do it, I might as well just start the camera and do it while people are looking over my shoulders. So yes, that's what we're doing today. Just putting a board together. Hey everybody, thanks for coming along. Oh, Ellen, yes, hello, live stream you can be a part of. So different time of day to usual. Yes, as Cable Tie says, that's live streams in a nutshell. Oh, Aaron, you're here. Awesome to see you. Thanks for coming along. I know the time zone really does not work for you, Aaron. So yeah, my normal live streams are at some ridiculous time for you. Yeah, there'll probably be a whole bunch of people here who I don't see very often. Okay, so the very brief recap. Let's go to, what are we going to go to? We're going to go, okay, Mr. Camera Person, I want you to take us to camera 3, please. So, the very quick recap. This is the interface board for the PCB conveyor project that I've been working on, not for very long now. It's a reasonably new project. I started this project because I'm going to be setting up some new pick and place machines soon, and I need to be able to link the pick and place machines together, and I need a conveyor belt that will convey PCBs from one to the other. So I started looking around at designs and ended up making my own. I won't go into all of that. I've shown that on the other live stream. So this is where we got to with assembling the board. Most of the critical parts have been put on it. All the surface mount stuff is done, the reflow is done, put on the voltage regulator module, and I started putting on some of the headers and things. And then kind of ran out of time because I had to go to a family function. So there is some more to do. Now, after the live stream, I was thinking more about this whole problem. So, for those of you who didn't see the live stream, one of the problems that I was facing was getting the spacing right. Now, this is an ESP32 based touch screen. It's a 3.5 inch full color touch screen. There's a, what is it, a Rover module, so it's an ESP32 on the back, and it's got this expansion header. It's the same header, it's just duplicated, so you can use whichever one you prefer. And USB-C, it's a really nice little module. On the live stream, what I did was I got some heat set nuts. So these are heat set inserts. These are brass threaded inserts that are meant to be heated up and pushed into plastic. Things like when you do 3D printing and you want a way to be able to screw things together in a nice way into a proper metal thread, these little inserts get put into the plastic and then they're permanently in place. And so what I did was I just popped them into the corner holes on this PCB and soldered them on. So we've now got threaded nuts soldered onto each of these, but we have a spacing problem. So with this header in place, I'm just going to push this in without any of the nuts or anything in place. Trying to grip it by the edge of the PCB so I don't damage the LCD. Now there is a gap here that we need to fill. So the bolt will come through, it's an M3 nut, the bolt will come through and into the M3 nut, and we need a spacer in there. And on the live stream what I did was I got some larger spacers and I cut them with a razor saw down to 4 millimeters, and they ended up being just slightly too small. So the result was that when the screws were put in, it sort of squeezed the PCB and bent it a little bit that way. So I think ideally I need 5 millimeter spacers. Now, plastic spacers are normally sold, oops, that one's gone for good. They're normally sold in, typically the ones I've seen are in 2 millimeter increments. So you can get 6 millimeter, 8 millimeter, 10, 12, etc. And I've never seen a 5 millimeter spacer. So what I talked about on the last live stream was maybe just 3D printing some spacers. But then I had an idea. Because you know the problem, I'm sure you've had this before, I've had it many times before. The situation where you've got a board that you're trying to clamp down And what you're trying to do is get a spacer in there. So what ends up happening, this is okay because they're right on the corner, But what I end up finding myself doing is doing something like getting a spacer and some tweezers and getting it in there and trying to hold it in place and get everything aligned, and then you're holding the nut on the back, and then you've got to get the thing through, and it's all just a pain. So I had an idea about making, I had this in my head, but I hadn't actually even looked at this since. So what you're seeing is me kind of thinking about this on the fly. What I was thinking about doing was designing something that I can 3D print. I'll make 4 little spaces that go on here. But instead of just making tubes, which is like this, I'm going to make it so that it's like a 2-stage tube. It's going to be probably about 3.4 millimeter diameter, internal diameter, maybe a fraction more, all the way through. But then I'm going to step it down so that it actually has like a sleeve that goes over the top of this nut and holds it in place. So I can pop it over and then it will just stay there. So I can pop on the 4 spaces, they will go around the nut, and then it will seat up against a little edge. And then I can just put this in place and the nuts aren't going to fall out. Then I can put the bolt through, everything will be beautiful. I hope. That's the theory. So before we do anything else, this is going to take just a little bit of messing around. Okay, Mr. Camera Person, I want camera 2. Let's do a little bit of messing around in Fusion 360. So what I was thinking of doing was making, this is going to be basically a series of circles. I need my calipers, and I need that. What do I need? Okay, let's work from the inside out. I'm going to make a 3.2 millimeter clearance hole for, that's so small, you can't even see it, for the middle. So this is a hole that's going to go all the way through. Now what I've just described may not have made a whole lot of sense to you. So, okay, what I'm going to do now is measure the diameter of, yes, unexpected fusion. I'm going to measure the diameter of this spacer. So this is the little heat set nut that I have soldered in there, and the outer diameter of it is 5 millimeters. It's knurled, which means that I've got to get it in the right spot to find the widest point. 5 millimeters. Okay, that sounds good. So let's make this next circle 5 millimeters, and then I need another circle which will be double the thickness. The difference will be double the thickness of the side wall, and I don't have a whole lot of room in one of these places. I might make it like a 1 millimeter side wall, so I'll say that's 7 millimeters. Okay, and now let's turn this thing into what is going on in my head, and we'll just see if it does work after all. So let's try, oh, and I also need some distances. Oh, that's right, this is easy because I was already saying that I was going to make this 5 millimeters. So let's extrude this 5 millimeters, and we'll turn that sketch back on, turn it back here, and this bit I'm going to bring down 2, maybe. How far down should I bring it so that it fits over? Now these nuts stand up about 2.9 millimeters above the PCB, but there is a little bit of a solder fillet around the bottom of them, so I can't bring it down all the way. So let's make it 2 millimeters. And this is, give or take, oh, back to the Fusion screen. Thanks for getting my attention. That one. That one is, that you just did not see me creating, is the shape that I'm talking about. So what this ends up being is a spacer that has, let's look at some dimensions. So that's a hole, it's a 3.2 millimeter diameter hole. So that's what the M3 bolt will pass through. And the outer diameter of the whole thing, no, let's not do that. Let's get, that is 7 millimeters. and it's got this inset. So the distance from there to there is 5 millimeters. So once this sits down on top of the nut, it should give me a 5 millimeter spacer above the nut. That's my theory anyway. So let's just save this. What am I going to call this? 5 millimeter nut spacer? That'll do. Kind of a nonsense name. Alright, so next thing, what are we going to do? Let's print this. Let's print a few of them. Save as mesh, and 3MF is good. Where am I going to stick it? Oh, PC, I was already in the right thing. 5 millimeter nut spacer, B1, yes, save. And I just need to slice that now. So I will bring up this window in just a moment. Projects, PCB conveyor, mechanical, and this is the folder that it just got put into. Where did it go? Yeah, 5 millimeter nut spacer. These are all the bits that I've been 3D printing for the PCB conveyor so far. So now we have a slicer. Where are we going to stick this? And I want more. Let's just do 4 for now. Auto arrange, that'll do. Printed right in the middle. No, but I want them up the other way. Let's put that face down, otherwise it's going to have an overhang. So now we'll be printing them. Ooh, let's see. Yes, the Space Mouse does work in Slicer. So now it'll be printing them upside down, but that's the correct way in terms of not having an overhang. So what am I going to do? Prusa PETG, that'll do. How long is it going to take? 11 minutes. We can wait 11 minutes. And do I have an... Yes, I've got the SD card here, so quit out of that. And so this is going to be kind of a stream of consciousness thing. It's just watching over my shoulder while I mess around and solve this problem. Come on, you can do it. Copy. I have some weird things going on sometimes with ejectable media, like SD cards on my computer. I just click the eject button and I'll sit here and wait for a minute. It'll get to a point where it probably will time out and then it will eject it anyway. Maybe it's just this particular thing. Come on, I ejected you. I'll click it again. I think it's actually finished writing to it. That happened pretty quickly. But there's something weird going on here. 9 AM. Yeah, see, it says couldn't eject it because it's being used. Nothing is using it. But then I just sit here and wait a little bit longer and it will say that it was ejected. Well then, why did you complain in the first place? Yeah, so I've got a, I do have a Raspberry Pi connected to that 3D printer with Octoprint on it, but yeah, see, now it's ejected. But I'm going to keep talking while I come over here. So I've got Octoprint on this with a Pi 3, but Octoprint has freaked out. It keeps repeatedly resetting the controller on the Prusa, and so I've just unplugged the USB cable and doing it off this SD card instead. I've got the, yeah, I've been running a touchscreen, so I've got a touchscreen Pi in a little 3D printed case mounted up over the top. Hang on, what are you looking at now? You're looking at my desktop and you can't see anything else. Let's just go to the front camera. You might partly be able to see. Where is the camera pointing? Not quite, my arm is there. So I'm just slightly off screen. But what I'm doing now, let's see, print from SD. Yes, I want to print the nut spacer. Go. And yeah, the Octoprint setup that I've got here is actually really, really nice. It's got a touch screen on it. It's a 5-inch, is it 5-inch or 7-inch? No, I think it's a 5-inch touchscreen mounted up on the enclosure for the printer. So if I've previously sliced something and loaded it into Octoprint, I can just walk up, use a touch screen, select it and hit print right from the printer. And I've also got the Octoprint thing set up in Prusa Slicer, so I can select the target and then I don't even have to save to disk. I just send straight to Octoprint from Prusa Slicer. But I think what I need to do, yeah, I'm getting some error, like Octoprint needs an update, and it's got into this cycle where it says it needs an update, and then I try to do the update and it says the update failed, and it just does that over and over again. So what I need to do is grab a fresh SD card and do a clean Octoprint installation, which what's put me off that is all of the effort involved in setting up the touchscreen dashboard again. I'm waiting for this thing to heat up. I'm going to leave that. It should be ready to go. It's trying to get its heated bed sorted. Right. Let's see. What's everybody talking about in the chat while that is warming up? Yeah. Oh, I just saw Dodgy saying, can't even blame my eyes at this time of the day for being fuzzy. Yeah, it's this camera is like a fixed, I've got it on a fixed focus because autofocus really sucks. Dave asked, what printer have I got? That one that I'm printing on right now is a Prusa Mark III S, and I also, you can't quite see it, on top of that cabinet right about there is a MakerBot cupcake, one of, I think it's cupcake number 172. It's one of the very early DIY 3D printers. And out in another room, which I just had to move, oh g'day intermittent, I have it's a printer that started life as a Mendelmax many years ago, and it has been through heaps of modifications. It's like not even recognizable anymore. Pretty much everything on it's been replaced. New extruder, new control board, new like a magnetic bed on it, and the cabling, I've redone all of the cabling in the Prusa style, so it's got the like the sleeves that come around with the, instead, yeah, the Mendelmax used to have drag chains, like cable chains on the side of the frame, and I didn't really like them. They were too big and not very nice, so I ended up going for the Prusa style cabling, which works out to be much nicer. Now, while that is thinking about printing, is it printing? Why have I not heard that start yet? Oh, there it goes. It's just starting now. I'm just going to clear a bit of the ooze out of it. There we go. And then it should be fine. And then in 11 minutes we should have ourselves some tasty little spaces. So in the meantime, I'm going to hit the soldering iron. Oh, and also I have some good news. Good news is always good. On Sunday I talked about the Stream Deck that I'd bought on Gumtree, and the seller had taken my money and then like acknowledged receiving it and then just stopped responding to any messages, including so not just messages through Gumtree, but also I had his mobile number, couldn't get in touch with him, and I thought that he'd just taken my money and run. Anyway, last night I got a message from him apologizing profusely, saying that he felt really bad, something had come up, and he hadn't sent the thing yet, but he's still going to, and offering to give me some of my money back for the trouble. So it seems that he had some kind of a personal emergency, and so maybe it's all going to work out in the end anyway. I haven't actually received it yet, and I haven't got confirmation that he sent it yet, but maybe, yeah, maybe it's just things getting in the way. So what are we doing? That's right, this. What I'm going to do now, I think, is just do a little bit more assembly. I'm going to put on these. I've got some stackable headers instead of regular headers, but that's just because it's what I happen to have in my little cache of, I like a little cache of headers. I've got bags and bags of pretty much every type of header in every size, every length. So I definitely do have heaps of non-stackable 8-way 0.1 inch sockets, but I can't be bothered getting them out, and I had these other ones right here in my local cache. So I am doing a cache read instead of going back to main memory. So what am I going to do? Which thing? Oh yeah, that's right, I changed to the K-tip again during the live stream, didn't I? So that is all set up, ready to go. Let's do a little bit of soldering. And I can hear the printer buzzing away in the background. Here's my little, I'll bring this in so you can see it. It's my little solder fume extractor thingy. It's a computer fan on a laser cut mount with some weights and some LED strip around it. So that's plugged into a 12 volt lead. I've got a few 12 volt leads just lying on the bench with DC jacks on them. So anytime I need 12 volts power, it's just right there. Running off connected to a big computer power supply which is mounted under the bench. So I always have 12 volts. Just plug it in and go. I think that needs a bit of reflow to get it to sit. And then I think both of those headers are good. So, I'm trying to do this without sticking my head under the camera, the usual problem. So I'm watching this from some distance away. And I don't have my extraction close enough, so it's blowing everywhere, wandering around everywhere. Come on. Not getting enough thermal transfer on the ground pad then. Okay. This board still has all that flux on it that I stuck on it, and I'm not wearing gloves, so I'm probably going to end up with flux all over my hands, which sucks. I'll get all sticky and horrible. Yeah, how do I get in there? Let's do it this way instead. Come on. It's not wetting the surface very well, even though this is hassle on the PCB. So hassle normally wets very easily. A little bit more on that one, just to get the all the little solder cones exactly the same size. There. Sticking in the flux. Okay, now another capacitor, not that one, I wanted the biggest one I can fit in there, 470 microfarad, 50 volts. That will do. Oh, while I'm doing this, just while I think about it, something that I had not done a good job of was providing any form of concise documentation or a getting started guide for the UT61E multimeter Wi-Fi interface. And there's been lots of talk about it because a lot of the work for that was done on the live stream, and then firmware was done by people far cleverer than myself. And there's the cool Node Red client. But the thing is that because it sort of grew over time with a few people contributing to it, I didn't have a neat way for people to get started using it. And there was kind of this assumption that people would have come along for the journey and they've seen the live streams and that sort of thing, so they know all the backstory of that particular thing. But I've had a couple of people buy that interface pre-made and then contact me saying, how the hell do I use this thing? So I'm just wandering around the room looking for headers. I'm actually wondering what sort of socket to put on here. I'm thinking about maybe putting a JST-XH connector on it, which is a 2.5 millimeter. It should go into a 2.54 hole. So what I'm talking about here are these connector things here. It's probably premature. I don't even need to put. So what I could do is put these JST-XH headers in there, or I could put a little keyed header, like a 0.1 inch header. Don't think it really matters. Okay, can termination. Let's stick in a can termination header. What color should we make that one? How about blue? Let's stick a, if I've got one here. I should have a strip, there, oh there we go. There's a strip of blue pin headers there. We'll make can termination blue, just to be different to the others. So what have I got? I've got yellow on the e-stop connection, I've got yellow on the limit connection, and I'll stick blue on the can termination connection. What was I saying? Oh, that's right, the UT61 multimeter interface. So there's all this really cool stuff, but there's no real one place to go that says plug in this cable and then load this firmware and then change this setting and this is how you do it. So today I just made a little quick start guide for it, which is now on the page for that project. superhouse.tv/UT61E should, or is it UT61E Wi-Fi? I think it's just UT61E. Should get people there. Ooh, I just noticed this slightly overlaps with the pins for the switch, but I think it's still acceptable. In fact, since I'm talking about that, let's put that switch on right now. This is the power switch. Ooh, that really is not so healthy, because what this is switching is, or am I using both the same? I can't remember. I should know if oh, it is. That's good. It doesn't matter. So what I was worried about is that there is a metal cap on the top of this electrolytic capacitor, and it's jammed up against the back of these pins, and I thought there would be a short circuit problem, but there actually isn't. It's safe, because those pins, let's see, where does power come in? So power comes in from through that diode from the header, and it then goes to these pins, which are it's actually it's a single pole, double pole, double throw switch, but that's actually one of the output poles is being used as the input. So there is no way, no matter where this switch is, that any voltage is going to be applied to these pins. They're not going to short anything. Yeah. Okay, I've just talked myself into it. I'm convinced now that it's safe. Oh, I'm going to change the soldering iron tip though, because I want the big thermal mass tip for doing this one. Okay. And I'm just going to put one of the pins in for now. I love being able to change tips like that. Previously I would work with multiple soldering irons. So I used to have a couple of Hakko FX888s, I think they are, or I can't remember what the part number is. Oh, I just heard the 3D printer finish. And I'd have one loaded with a large tip for big thermal mass and another one loaded with a K tip for drag soldering and more general work. And I just reached for whichever iron I wanted, but it's a bit of a pain having the two soldering irons. So having an iron like this that does everything from big chunky tips to, you know, tiny little things, and there's a holder, I can just pull the tip out, stick the other one in, and before I've even had time to take breath, it's up to temperature and ready to go. Alright, so that means that will be on, that will be off. Yes, I've heard that 3D printer finish, but I'm going to leave that for just a moment because I'll let it cool down and those things should pop off. So I'm going to put on the CAN bus header. I'm going to get out my box of pluggable screw terminals. In recent times, I've really come to love these, the 3.81mm pluggable screw terminals. So I've got them, hang on, let's see if that camera is too zoomed in to see. We'll go for this one instead. So I've got this big tub of them, and inside, so these are all Ziploc bags, I've got supplies of things like 4-pin socket right angle, and just near it will be, where is it? Oh, there's 4-pin plug, and there's 4-pin straight, and then I've got 5-pin socket right angle, 5-pin socket, 5-pin plug. Like all of the useful sizes, or all the sizes that I use commonly, are in here. So what I'm looking for this time is the one that I think I just had in my hand a minute ago. Oh, I'm going to need a 4-pin plug. And no, that is not all the 4-pin plugs I have. That's also 4-pin plugs. Okay, where are, oh, there they are. So 4-pin socket straight. I'm going to stick one of those on. I actually need 2, but will I populate both? So this is the thing. Do I keep populating, or do I start testing at the point where I can get power to it and a connection? And I think I might start testing at the point where I can get power to it. Now, which way does this go? We want that. So this is, oh, also something else I should explain about this design. I'm going to grab another one of these connectors out. That is the 4-pin straight, and I've just got a 4-pin right angle. So in designing this PCB, I was thinking about how it might be used and what sort of enclosure it will go into. And so this is going to end up mounted on the back of this. In fact, it's going to be mounted there in just a moment if those spacers have worked. So that'll be mounted on the back there with the touchscreen visible at the front, be able to get to the UI, and then on the back the cables will plug in, and then the whole thing will be inside an enclosure that mounts it on the front of the conveyor belt assembly, and it will hold the screen at probably about a 45-degree angle for easy access. So there are a couple of ways this can be enclosed. If it's mounted on the front of the conveyor belt, what I intend to do is use sockets that go straight up like that, so that the cable will plug in and come in through the back of the enclosure. So that will plug in that way and come in straight from the back of the enclosure, or the cable will be routed internally or something. But I was thinking about alternative uses for this board, and this could be really, really useful as like a little standalone handheld device in a rectangular enclosure. So if I make an enclosure that just essentially puts this whole thing in a little box that's no bigger than it needs to be, what I could do is use a right angle socket instead, like this one. It goes in there, and then it could be something like a user interface box with a cable that plugs in the side, and it could just be sat down on a bench. And because this has got CAN bus and power on it, it could be useful as a little touchscreen CAN bus controller user interface device. So I put a little inset on the PCB there to allow some extra clearance, so that if that is in right angle mode, there is plenty of room. Turns out that I didn't actually need that, but I could have just made it a straight angle. So what I'm going to do for this purpose is populate this with a straight socket. So it'll be one of those. Which way around? That way? No, that way. Yeah, populate it with this, and the cable will come straight out the back instead of the convenient lying on the bench sort of orientation. So solder on the can low, and yep, that's all bedded down now, sitting flat. So, now I've got to get this slightly warmed up blue tack out of there, which is horrible. Okay, so we can now bring power in here. We've got a voltage regulator on it. We've got the power switch. We've got the can termination header. I might I'll stick a jumper across that now. Do I have a blue jumper? No, I've got a green one. Let's stick a green jumper on a blue header. There we go. So the very first thing to do, I think, is to apply power to this and make sure that it doesn't draw any excessive current. Before I plug it into this or do anything else, I just want to make sure that if I supply, say, 12 volts in here, I'm going to get 5 volts out of the regulator, and the 5 volts is then fed into this, which regulates it to 3.3 volts, and then it's brought back onto this board, and 3.3 volts is used on here. So what I want to do then is find myself, here we go, this cable right here, which is ready to go. My bench power supply comes out to XT60 connectors. So which one do I want to use? I've got power supply 1 is already turned on. It's at 24 volts. Let's use power supply 1, and then we want it's positive and negative. This pinout should match. It's a standard pinout that I use on these connectors. The other thing that's interesting about these connectors is, see, we've got a 4-pin plug here and a 4-pin socket, which obviously fits. But the way these pluggable terminal blocks are designed, one thing that is bad is it allows you to do an offset like that. You can actually plug it in the wrong place, because the spacing on all of these is exactly the same. There's no additional on the end, like there's no extra thickness on the end, which means that you can plug these in any position. And if I've got a 4-pin socket like that, I can take a 2-pin plug and just plug it in. It works perfectly. You can even put 2-pin plugs in parallel, like in side by side, into a 4-pin socket. So you can mix and match your things like that. So I've got this power lead coming from my lab supply, positive to positive, negative to negative. I don't have the power supply turned on yet. There's no power LED anywhere on this board. I don't know if that's an oversight or not, but that's just the way it is. Now, I know what I can do. I'm going to turn that on, and since I fixed it, oh no, I can't show it to you. How can I show it to you? Oh, I know how I can. This is going to be super dodgy, but it should work. I'm going to have to switch camera views a couple of times to show you. Right now, I have no way of bringing the multimeter interface up on screen, just because of the way that this is all set up. So let me bring up the interface on my desktop computer. I've got to go to the IP. What is the IP of 185.1880 UT61E? There we go. Okay, so just to show you what I mean, I'm going to bring this up to the top monitor, and the proportions are all off, but if I go to that, you can see the that's the live multimeter view. And yeah, I know I've got to do it on the whole screen, but for now what I'm going to do is bring this up, and multimeter is here, and I'm going to set the current limit down. It's set to 6 amps at the moment. That is a bit ambitious. Let's go I set 0.1, enter. So I've got it set to 100 milliamps. All right, this is the big moment. We're going to see if the smoke comes out. Oh, the switch is off at the moment, so nothing should happen, but I'm going to probe on the switch before anything else happens. So lab power supply turning on now. And there is 0 current being pulled, which is good. So what I expect to see, if I probe, so that's a negative just there. If I probe on this side, I should get, oh, it still sets 24 volts. Oops, good thing I hadn't tried it yet. VSET 12, go. All right, so 12 volts. And if I do that, you will be able to see, I'm going to do the same thing. So at the moment you can't see the overhead camera and the desktop at the same time, just because of the way the ATEM Mini works. So there you can see I've got 11.95 volts being read, and if I flick the switch, there was no explosion. That's another good sign. I now have, so that is on the outside of the switch. Now let's see, I'm going to put these probes, you can't see what I'm doing unfortunately, but I'm going to put the probes on the output of the 5 volt regulator, and we got 5.05, 5.06 volts. Very good. Alright, so the voltage regulator part of it seems to be doing what it's meant to. That's a good sign. What else should I measure? There's probably not a whole lot else to check until I have it plugged into the, plugged in. Oh, before I do anything else, I'm going to solder in the stepper headers. Okay, so I'm going to come back to here, because once I actually mount this on the screen and screw it all together, I'm just going to turn off the lab supply. It is not going to be so easy to, like, it means I have to unscrew it all and take it off in order to add more stuff, because the solder joints are on the bottom. And I want to take it off and chuck it in the ultrasonic bath anyway, but for testing purposes, what I'm going to do is solder on the headers that go to the stepper motors. And yeah, so on the subject of showing the multimeter on the screen, I have my initial feeling when I got the ATEM Mini was that I hated it, because I was disappointed. It didn't do what I expected, and that is largely because my expectations were not accurate. I thought that what it would be the equivalent of OBS in a little dedicated box, and it's not. It's nothing like that. It works in a very different way. And so over the last little while, I've been making a concerted effort to use the ATEM. So right now I am streaming entirely off the ATEM, not using OBS at all. It's just 100% ATEM doing everything, doing the picture-in-picture and all that sort of stuff. Even audio, so the audio is coming into a radio microphone receiver which is plugged directly into the ATEM. So even the audio is not going through my computer. All the computer does is have its screen captured via HDMI. And that means that there is no extra load on the computer to be doing the streaming. And anyway, I've kind of gone all in on using the ATEM for it, and now I really, really like it. But the big problem that I've found is going all in, I don't have enough channels on it. It's only 4 input channels. It can capture 4 HDMI sources at a time, and I need at least 5, more likely 6 or 7, to be able to set this up properly and capture everything that I want to. And I also need to run OBS in an external on the laptop and feed that in, so I can capture things like the multimeter interface and the oscilloscope interface and overlay those, and then chroma key the rest of the screen out. What am I doing now? I'm talking about stuff without actually doing anything. I need to keep moving instead of stalling and talking. So where does that leave me? where it leaves me is I'm going to upgrade from an ATEM Mini to a Mini Extreme, which is the 8-port version, and it gives me a bunch of benefits. Firstly, the extra inputs that I really need, but it also allows more overlays because it's got more upstream and downstream keyers. So at the moment what I can do is have the camera view that you're seeing, which is the overhead camera, and one picture-in-picture with the, and that's the limitation of the Mini. But the Mini Extreme allows you to overlay a whole lot more. There's much more that it can do. So I can have things like the multimeter interface and the oscilloscope interface being brought in via HDMI capture from OBS on another computer and overlaid onto the screen, while we have the overhead. We could have the overhead camera, the multimeter, the microscope, and like a face camera all at the same time visible on the screen. So it will, yeah, it'll allow a whole lot more stuff. What else do I need to put on before I do this? Okay, I'm gonna head it back over to the printer because it should be well and truly cool by now. I finished this print ages ago. Yeah, it's almost down to room temperature. And let's have a look at how these turned out. Just moving some stuff out of the way. So this is what just came off the printer. So we've got 4 of these. Give it a little bit of a flex. Not that I need it because they're so small, I'll just pop them off. Oh, and this is not an original Prusa build plate. I ordered a replacement because I burned out my original, and then the heated bed. Sorry, I burnt out the heated bed. So I ordered a third-party replacement, and it came with a new build plate just in part of the kit. And I started using that instead of the original Prusa one, and I prefer it. It works really well. Okay, check this out. It's a little bit loose. I think if I'm going to, for the next version, I'm going to slightly decrease the diameter of the inside hole. I'm going to stick this under the microscope so you can see what I mean. But that is actually okay. So what I can do is put those spacers on, and unlike normal spacers, they won't just fall off. So I can do that and put this on and then put bolts through. Should be much easier than, yeah, see, I can turn it almost sideways and they don't fall off. Much easier than using just little spacers like this that sit on top of the nut. But just a fraction too loose. It needs to be like a friction press fit so that I can turn it upside down and have them not fall off. And they're kind of borderline at the moment. What was I going for? That's right, I want to change to microscope. So what we're doing is, that is the heat set nut that I soldered onto the PCB on the live stream, and there is the little spacer you can see with the 2-stage diameter that fits over the top of the nut. It just pushes on. Yeah, still just a little bit loose, but the principle works. Cool. I like that. That kind of worked out all right. So now I am going to put these back on. Yeah, a little bit loose. And put this on. And hopefully the pin header will still be able to reach through and make good connection underneath. I think I probably need to shorten these by a fraction as well. It's sitting up just a little bit too high. I think I would take, if I took 1 millimeter off, I think it might be too much. If I took 0.5 millimeter off, I think that would end up being just nice. So what I'm going to do is, oh, and you can see that they're not falling out like normal spacers would. Well, so I'm just going to chuck these through, and maybe I will go to the trouble of going back to Fusion and doing that change now. I won't stop for that for doing other things. Yeah, no, I'll do that later. I won't do that on the live stream because I want to see this thing powered up and doing something. Yeah, that should be inserted enough that there is actually an electrical connection there. It's just not properly bedded down. So, getting flux on my hands. So, we should now have something that we can power up, connect CAN bus. We should be able to see the MCP23017 on the I2C bus. We should, what else should we be able to do? We could possibly run a test to drive a stepper motor if we put stepper drivers in here. So as a first step, what we can do, I'm just going to power this up. I'm not going to do anything unusual to it because I just want to show you what happens. Is this going to reach? I need my USB hub just a little bit closer. Yes, I can make it reach and still be on camera, I think. Alright. Oh, it's upside down, but you get the idea. So it's going through different colors. It's coming up with a screen, and this is a demonstration of the touch screen. There's a little box and a track. So what I can do now is touch that and drag the box along the track, and that unlocks it, and then it comes to some screen. I don't know what that says. I haven't tried doing a translation of that, and I think it just shows that. So what we're seeing right now is this device is being powered off USB. You can't quite see it, the cable is just off the edge of the screen there, but if I pop that off, what we should be able to do now is plug in my bench power supply. Where did that cable go? Right there in front of me. Power supply is turned off. Just going to make sure I get positive to positive. Alright, so we now have no USB connection on here. It is just being powered through my board, which goes through the 5-volt regulator module, which feeds through the header to the touchscreen unit. So, and at the moment the power switch is off, I think. Yes, that's off. So here's what we're going to do. I'm going to turn on the lab supply. Oh, it's currently still set to 100 milliamp current limit. I need a bit more than that. I set 0.5, go. All right, so 500 milliamp current limit at 12 volts, which gets stepped down, so we get like an amp or so out of it. I'm going to flick this switch. This is the big moment of truth. Is it going to be powered off the new board? Turn it on. Oh yes, look at this. It's alive. So green, blue, and then we can do the touchscreen thing. Come on, move it there. That's it. So it is alive, being powered off our board. Is it getting warm? No. How much is it pulling? It's pulling 80 milliamps at 12 volts. What? Seriously? Is that all? So yeah, 0.96 watts according to the bench power supply, which is something else that I want to be able to stick up on the screen so that you can see it. So right now it is pulling approximately 1 watt, and it is running the ESP32. It's got the touchscreen active. You can see the backlight is on, and yeah, that is pretty cool. No smoke so far. So what next? I think next thing is going to be Let's just load an I2C scanner and see if we can see the MCP chip, just to verify that the I2C bus is alive, which I'm pretty sure it has to be because the touchscreen uses I2C, I think, although it might be a second I2C interface. I'm not really sure. Alright, just going to turn it off, turn off the lab supply, unplug it. But yeah, this is quite a cool little unit. This in a box with a CAN bus connector on the side. Yeah, I can see all sorts of uses for this. Very, very useful. Display CAN messages on here, like live updating messages, and be able to send CAN messages, have, you know, virtual buttons on it, user interface. So handy. All right. Stepper motor. That's right, yes. Let's, for this next stage, I don't think we want the overhead camera, and you don't even need to see the device. So what's going on? I've been doing my usual thing of totally ignoring the chat. So let's do a little catch up. David S said, looks good so far. Yes. Yes. That is very cool. David T, text demo? Okay, I don't know. There are probably all sorts of demos that can run on this board. Now, what I'm going to look for now is I'm going to launch Arduino, and I'm going to, what are we going to do? We're going to come back to here, and once the IDE is up, I'm going to bring it up onto that screen. So, what else do we have on there? Oh yeah, I'll close that now. In fact, the multimeter's still running, but I'll turn that off. The interface is unplugged, which is why there was no data coming in. Let's just come back in here and do a little bit of a tweak. Come on. Edit that. Now the inner diameter is fine. It was this diameter, so 5mm. This is the one where it slides over the outside of the nut. Let's make that 4.8 instead of 5. We'll just take 0.2 mm off it, which will make it like a tightish press fit. And then I don't want it to be quite so high, so instead of a 5mm extrusion, let's make it 4.5mm. Okay, so I just want to verify that I got the right thing there. So I want to go from, oh yeah, that tube, what is its length? Loop length? No, that's no use to us. I want from there to there is 4.5mm. Yes, good, okay. So that is a fixed, maybe I could decrease the outer diameter a little as well. And what I could do is I'm going to fill it, I'm going to chamfer that by, I don't know, just a bit. Pull it in, because that way it'll clear any of the solder fillet. Let's make it just 0.5mm. Yeah, that'll do. Cool. So I think that'll work just nicely. Save, go. Oh, I just saw someone said hilltop hoods. Yes. I haven't heard any hilltop hoods for a while. So what was I doing? That's right. Anyway, will I, won't I? No, I'm gonna get out of Fusion 360 because I'm not gonna bother doing that now on the live stream. We're already an hour in and I've hardly done anything. Oh, put these sprint again, Henrik says. Okay, no, because then I'd have to pull the thing apart. I will do it, but I won't do it on the live stream. There's no particular need to wait for that on the live stream right now. So what I'm going to do is look for sketchbook. I am looking for my I2C scanner, which is there. I think this is the one that works on ESP32. Should be, yes, I believe it is. So this is a little sketch that I've got to check whether it's these pins. So what this does is just open a connection via I2C, and then it loops through all possible addresses from 1 to 127. It checks whether there is a device there, and then if there is, it tells us what it is. Unknown error. Haha, let's fix that. Unknown error at address. Hex blah. So what do I want to know? That's right, I want to know what pins. And I can't remember. Did I write it on the PCB? Normally I try to put pinouts printed on the silk screen, but I don't think I did on this one. No, I didn't. So instead, let's look it up in Eagle. Projects. I'll bring this up on screen in just a second. What am I looking for? Conveyor, PCB conveyor, hardware, board, okie dokie. So, there's that one. It's only showing one of the layers. And schematic. So did I make a note of the... Normally in my schematics I try to put a text box in here with a list of a few things. The pinouts is the critical thing, and things like a list of I2C addresses, and the pinouts does things like show you SPI chip select, so I list all the different devices for that, but I have not yet done that on here. Okay, so what am I looking for? I'm looking for SDA is 18, SCL is 19. So I think what that means is, and I never know I can never remember which way around. 18, 19. Let's try this. And what board have we got it set for? ESP32 dev module, who knows. That one? My guess is it's that one. Let's do an upload and see what happens. So, because there are only 2 possible orders this can be in, I normally just take a guess, and if it doesn't work, I just swap the numbers. But the constructor for the wire object, or for the begin method, I think is SDA, so it's data and then clock. I think that's the way around it goes. Uploading, what have we got on the monitor, if anything? Oh, here we go. Look at this. This is the serial monitor. Scanning I2C device found at address hex 38. Hex 38? What? Is that a number that even makes sense for an MCP2307, or is that some other device that I'm finding? So there's the CAN bus interface. What else do we have? I don't have anything else that is... so let's check. I can't even remember what MCP23017 I2C address. What is its address range? Oh, okay. 32 decimal to 37 decimal, or 20 to 27. MCP23017. So what was I seeing? I can't remember. It was 38, wasn't it? So it's probably not even that device. Looks like we may not be seeing the device. 38 may be the touchscreen interface, perhaps. I do have, let's see, Superhouse, projects, PCB conveyor, firmware. Alright, so this is the various stuff that I've been doing so far. ESP Wi-Fi analyzer, PCB conveyor, stepper motor G-code, stepper motor menu. What do I want to try? Oh, cap touch test, yes. So let's see if this exposes. Where is that window going to open? There. So it's using that. I think what we might be seeing, 18 and 19. Is that what I had here? 18 and 19, yes, hooray. I think what we might be seeing here is the cap touch chip, and we're not seeing the MCP23017, which I'm not dramatically concerned about. It's probably an assembly fault or something. I'm sure I can figure that out. But just for the fun of it, let's just load this and check that the touchscreen is working. So it'll be interesting if the touchscreen is working when it's not seeing the MCP, because at least that means the I2C bus is working. Working to some extent. Alright, did that finish uploading? I think it did. Now, where... I can't even see where it is. Oh, there we go, look at this. So on the screen, I will try to hold this up in front of the face camera so you can see it. So we've got this, and on the screen you can see the X and Y coordinates. And now if I stick my finger on here, we'll get a stream of data. And if I stop moving, it stops. So down in this corner, we've got 0, 0, and then move it up towards the other corner diagonally. Hang on, why did that number go down? I don't know. So Y, it's I think it's set up for that orientation. And also I'm looking at it backwards because I'm holding it towards the camera. So if I go right in the middle and then move, say I'll move to the top left corner, Y goes low and Y, no, so Y must be set up for that orientation. So Y going high that way, Y going low that way, and X going high that way, X going low that way. X up, no, that, X, so X is horizontal, X going up, X going down, and then Y going down, Y going up. So it's like one of the axes is reversed. Yeah, I can't actually get them both going the way I expect, but it doesn't matter. We've got coordinates coming out at least, and that's the important thing. And what happens if it does support multi-touch, but I don't think this little simple test actually reports it properly. So if we had buttons on the screen, we'd be able to detect whether there was a press within the button region, if you know what the regions are and you have them defined. So we can do code for a little user interface, and we can do sliders and things, which is all cool. Where am I? Let's go back to the chat for a minute. And the screen, maybe the screen. I see this kind of address as well a lot with a number and a letter. Interfaces. Okay. Terminate. Accidentally slipped into the fourth dimension. Yeah, I was going the wrong way. Okay, on PCs, 0, 0 origin is top left, so it seems right. Okay, yes, okay, so I'm thinking about it from a Cartesian point of view where positive X is to the right and positive Y is up, but if your origin is in the top left corner and you're going across and down, then yeah, Mitchell, you are perfectly correct. And that is historically because user interfaces were designed to work on a computer screen where the origin is top left, because you don't actually know how wide the screen is or how high the screen is. And the top left corner was the easiest place to have a fixed origin and then have menus and things coming out relative to that, because menus you want to come from the top down and you want to have things going across from the left out. Yeah, so for computer graphics, origin it's pretty common to have origin in the top left. not the bottom left, which is what my brain says it should be. Okay, what am I doing? Yeah, okay. Couple of things I could do at this point. One is I could try connecting CAN bus and see if we can see any messages on the CAN bus. The other is I could try debugging this MCP problem. I am inclined to try the CAN bus just to see if it works, because I don't know, there are two ways I could go with this process. One way is you can either check everything and not try to fix anything, just move on, or you can check something and if it's not working, fix it, stay focused on it until it's done. So that second approach, I've just discovered that I can't see the MCP, which I expect to be able to see. So the next step is to debug why I can't see it before I test anything else. But I'm kind of inclined to move on and just see if CAN bus works. And because that is, like the MCP, I've used them so many times before, I'm not really that fussed about it. I'm pretty sure that I can get that sorted out. So it'll probably just be, unless I made a mistake on the PCB, which is quite possible, it's probably just like a bad solder joint or something when I was doing the assembly, or some other, you know, stupid little thing like that. I'm pretty confident that I'll be able to figure out exactly what's going on with it. So instead, I think what I'll do is look at CAN bus. Yes, so I'm just thinking about how to do this, what device I can get to talk to it, and what firmware I can use, because I have a bunch of CAN firmware for ESP32s for commercial products, and what I'm thinking of doing is actually hooking it up to the water cannon. That if I switch back to here, wrong way. The water cannon just there uses CAN bus. And what I could do is maybe do some firmware that just watches CAN bus. Oh, here Jackstack says, shoot the X and Y out over CAN as messages. That'd be pretty cool. But this is at the point where hours can go by messing around with this stuff, and I don't really want to be here for hours tonight. This was just getting to the starting point, really, and we're now at the starting point, and going beyond this is kind of just a some extras. Giles or Gillies had or Robert perhaps had a suggestion. Is your extension board powered from the screen board? MCP not powered maybe. Yeah, that is a very good, oh yeah, Jack's Tech, touchscreen joystick, exactly. Control the water cannon with the touchscreen. So that is a very good point. That would probably be the first debugging thing, is to stick the meter on this and make sure that the MCP actually has power. So there should be 3.3 volts on it. And because, so what's happening is that power, I wonder if it's because I'm powering it via USB. Yeah, I'm just wondering if I go down this train of thought or not. So the way I intended for this to work is not power it by USB, power it via the CAN bus connection. So say 12 volts or 24 volts comes in there. It then gets regulated to 5 volts on here. That 5 volts gets injected and to pass through basically to the touchscreen module, which has it's actually got two 3.3 volt regulators on it, and then 3.3 volts comes back out to the top board, so there should be 3.3 volts on it. I haven't actually checked whether we're getting 3.3 volts back on that top board. Yeah, maybe that is the best thing to check right now. Let's check that. I am going to, just for cable length purposes, I'm going to unplug USB and we are going to switch back. Oh, I shouldn't have closed the window I had open that had the multimeter open. UT61, there it is. No, not that. Wrong one. I was just opening the GitHub repo. I want 192, what's the IP, and 1880, and UT61E, and there we go again. Okay, so now we have the multimeter view back, and I'm going to switch to the overhead camera temporarily. Alright, so I need to find out where we should have 3.3 volts. So what I'm going to do is bring in power from the bench supply. So 12 volts coming in, turn that on. That's now on, and we should be able to see, oh, if I turn on the multimeter, that makes it work better. And we should be able to see 5 volts there. Oh, if I turn on the power switch, that also helps. So 5 volts there. Okay, so we've got 5 volts coming in. Now what pin should I be seeing the, if I come back to here and back to the board layout, where should I be seeing 5 volts? GPIOB 3.3 volts. Okay, I should be seeing 3.3 volts there, and ground is easy to find. Oh, and 3.3 volts on the limit sensor, the center pin, and ground directly above it. Look at that. Very handy. Okay, so I can use this to check whether I have 3.3 volts on this board. So, back to, where am I going? Back to there. Hang on, why don't I have any data coming up? What's going on with that? Oh, because, for the most obvious reason of all, is it plugged in? No. Okay, we should get some data coming up any moment now. Any moment now. Any moment. Okay, so I should be able to get 3.3 volts if I measure between that pin and that pin. And I do. Nice. Okay, so we are getting 3.3 volts. And just to check, I'm going to do it on the pin of the MCP, which you won't be able to see, but that is the power pin of the MCP. Alright, so it is getting 3.3 volts. Alright, it's getting power. Next thing I would do is check the I2C signals are getting through and on the correct pins and all of that sort of thing. But at least we know that we're getting power coming back up through it. Something else that would be interesting though, I'm going to unplug the bench supply. I know this falls into the highly unlikely category. Hang on, I've got something here I'm going to unplug. I don't actually know what this is going to do. Alright, here we go. Did I lose anything critical? No. I've just unplugged something on my USB hub and I don't know what it is. Alright, so I'm now going to power this off USB and we'll see if we still get 3.3 volts coming up onto the top, because that may have been the problem. Okay, so ground and there. Oh yeah, we do. Even when it's powered off USB, we get the 3.3 volts. So it wasn't that. But for a troubleshooting step, that was very worthwhile. So thank you for that suggestion. At least we've verified power is getting to the chip. And so now we can look at, yeah, I'm going to ignore that MCP for a little while now. So where is my, where's my cursor? I can't find it. I've lost my cursor. Oh, I know why. That thing that I unplugged a moment ago, turns out it was the trackball for my computer. Okay, now we're back. Now, what do we want to do? Let's let's I just want to check, while I've still got this open, what pins have I used for the CAN bus interface. So I've got, where is it? I want CAN RX. So CAN RX is 4. Where's CAN TX? Is 5. Okay. So RX and TX are 4 and 5. And yeah, testing this is actually going to take a fair bit of stuffing around. And I'm really going over and over this in my head, because to do this, the easiest way for me to do it would be to use a connection to the water cannon and to use the same firmware, or base it on the same firmware as I run on the Canon controller. But that is commercial. It's owned by my client. It's not open source, so I can't show it. So let's what can I do? All right, let me see if I can find some other firmware that might be a very quick starting point, because I don't want to have to create a whole bunch of stuff from scratch. I'd rather find something that I've got that already uses CAN bus and then just do a quick hack to you know, to show I just want to test comms, like really basic stuff. What am I going to find? Thinking about projects that I've done that use CAN. What could I start from? I could use one of the wheelchair projects. That's probably as good a place as any. Yes, let's do that. In fact, what I could do is use the wheelchair hand heater firmware as a starting point. Yeah. All right. We have a plan. Let me get this up. Citizen Blank suggested the window opener. No, that uses LinBus, which is like a subset of CAN bus. It's a different driver. So I want to go to Superhouse, Projects, Hand Heater, Firmware, Hand Heater Firmware, and Open. All right, I will bring this up on the screen in just a jiffy. So, yeah, Aaron said wheelchair joystick. Yeah, I've got a heap of assistive technology projects with CAN bus in them. So all I want is something that's going to do some, that will have a debug mode that I can turn on, and it will just spit out all the CAN bus messages that it sees, and then I will be able to, sorry, I'm doing some stuff off screen at the moment because this is revealing things like Wi-Fi details. And for this particular thing, this wheelchair hand heater that I'm working on right now, like this firmware that I've got open right now, last time I was working at it, I was at Chris's house and it's got his Wi-Fi details in it. So I definitely can't put this on the stream. Just putting my own details in there, and then I'm going to hide the config file. It's got an MQTT broker setting, Bluetooth. No, we do not want an CAN true, Bluetooth false, MQTT true. And I'm going to turn off MQTT because all I want to do is, I'm going to turn off Wi-Fi too. All I want to do is see the CAN messages. So where are the CAN bus settings? So RX is 4, TX is 5. I've got that set properly. What CAN bus frequency does it have set? I think I'm just about at the point where I'm going to be able to bring this up on screen now and show you. Okay, here we go. Oh, first I'm just going to see if it compiles. Alright, so this is the wheelchair hand heater firmware. Wi-Fi was not declared in this scope. Okay, I'm going to... I killed Wi-Fi because I was going to try to work around it, but let's try this. Okay, without making other changes, I'm just going to try compiling it. So the first thing is just to make sure that the firmware compiles at all before I start hacking around on it. Otherwise I won't know if I've broken it or if it was broken to begin with. And I can't even remember the state of this firmware. I think it's working pretty well. Like on the wheelchair hand heater, this is the current version and it does everything. Like it's got Bluetooth and Wi-Fi and MQTT and stuff, so Chris can control it from his phone, and from the home automation system can link to the wheelchair system. So yes. And right, what am I looking for? Okay, so can speed 500 kilobits a second, that is good. And what I want is some CAN debugging. Now this particular project is not very neatly structured. It's got this one source file that, as you can see by the state of the slider, is long. It's got everything in it. Ooh, enable MQTT, fan taco reading, can, process MQTT. What I'm just looking for is where the callback that is used for CAN bus messages. There's Bluetooth, CAN. Okay, CAN receive frame, check CAN bus, and it's checking for different things and then processing them. I'm going to turn off responses, and I'm just going to uncomment a whole lot of this debugging stuff that was in there before. Check if we've been setting up for blah. Frame. I don't care about any of that, so I'm just going to comment that out. This is going to be, what you're going to be witnessing is like wholesale nasty slash and that doesn't work. Lots of nasty wholesale commenting stuff out, just brute force fix it stuff. And I just screwed that up because I did not comment out one of the curly brackets properly. Back to enable CAN. So what have we done? I've commented out that, and oh, that was it. It's because I can't type good. That's better. Right. So now what it should do is, if it receives a frame on the CAN bus, it should just dump out, it'll say whether it's received a standard frame or an extended frame, and it'll dump out what it got, like what device originated it, and yeah, so the frame, the message, blah, all that stuff. And I don't actually care about any of that. This is not going to do anything because the guts of that check have been commented out. So if we load this onto it, I'm just going to stick it on right now. There are some things that this could break. LED flasher was not declared. That'll be because of it's not the LED flasher, it's because I've screwed up. Yes, I have still screwed up the brackets. Where is that CAN bus function? Void check CAN bus, there we go. I over commented out, I believe. Maybe this will be a little bit happier now. Yes, that should be happier. Now, where this might fall down is that there are some pins on the touchscreen board that are used for things like the SPI connection to the touch controller. Is it even plugged in? No, it's not. It is much, much easier to upload to things when they're plugged in. That is a good rule to live by. Where's the connection? There it is. Okay, so let's try that one again it yeah, so there are things in this wheelchair hand heater code that will be doing stuff to pins that may actually be a problem. I might have to go through and do like a bigger wholesale, just gut it sort of thing, deleting a whole bunch of stuff so that it doesn't do anything except give us some debugging. Okay, now I am going to get this water cannon up and running, which hopefully will not take very long. So what have we got? Okay, I've got the joystick over here, which is running on CAN bus. It's all out of focus and off frame now, but yeah, this is the controller for the water cannon. This cable has power and CAN bus on it, and this is the cable that goes to the power supply, so I'll plug that in. I'll turn the power supply off first. Set the power supply to 24 volts and I'll stick it back up to 6 amps. V set 24 go, I set 6 go. So if I just turn this on now, we get some beeps, and it's just on the edge of your field of view, but so I can now run the water cannon. So next I need to make a link that is going to take the CAN bus off that and loop it through. So I think I need a few bits of wire. Let's start by turning it off. Now I'm going to pull this out, chuck that back on, and then switch to that one. Alright, so this is the joystick that I was just using to control it. I've just disconnected the CAN bus thing. In fact, this here, oh, I just realized I can probably do this without doing anything at all. This connector right here, this pluggable connector, is the connector that goes onto the control board inside this joystick, and it has the exact same pin out. I was actually deliberate about this. It has the exact same pin out as this connector here. So if I just plug this straight in like that, and then turn on the power to the water cannon, let's see if any smoke comes out. It didn't. Okay, so the water cannon won't do anything because the joystick isn't even plugged in. It's bypassed. But the water cannon will be sending status reports via CAN bus, and we should be able to see them now if we go into the debug that is coming up there. So let's see what we can find. Oh, look at this! CAN bus is working. So yeah, this is the debugging coming out of the touchscreen board. Look, you can see, oh yeah, some of those messages. I'm going to turn off auto scroll. Fan speed 0 RPM, target temperature 0, actual temperature 23. These messages are just status reports from the wheelchair hand heater, and that's because it's just running on this board that doesn't even have the hardware. Like, it's got no temperature sensor on it. It's got, although it's saying actual temperature. I don't know where it's getting that from. Fan speed 0. Yeah, none of its normal heater type peripherals are connected. But the critical thing, we are getting these CAN frames. These ones that you see here are actually being transmitted on CAN bus by the water cannon. This is it doing its regular status updates that come back to the control system, talking about things like whether it's hit any of its travel limits and what temperature the controller is currently at, and current limits, and all that sort of stuff. So that data, which we're not decoding, we're just this is the, if we come back in here, all we're doing is saying, hey, we got a message. So I think this qualifies for a totally unconditional woohoo! We have CAN success. Yeah. Cable tie says, I hope the water's not connected to the water cannon. No, it's not. I don't even have a pump here. So, Iggy said, did I check the outside height, not just that internal extrusion? Are you talking about the little spaces? Maybe? I guess so. The CAN bus terminator is going to be good. Yeah. Well, there is a CAN. Oh, I see what you're saying. Yeah, you were thinking this was back when I was going to connect all 3 devices. So what I would have done in that situation is remove the CAN terminator from the middle device, and it would probably still work with the 3 termination resistors in place. But yes, in the end, I didn't need to do that because I just bypassed the joystick entirely. I'm really happy about that. So we now have an ESP32 board with a touchscreen interface, and we've verified the touchscreen is working. We know the screen is working, and CAN bus is working. So, like, apart from that, whatever's going on with the MCP, even without the MCP, the power supply part is working. So this is running off 24 volts right now. It's getting 24 volts from the CAN connection from the Canon, and it is powered up and running. So it's reporting over USB, but the power is coming in through the, yeah, so it is getting power from the CAN bus connection. So far, this is feeling pretty good to me. I like where this is going. Yeah, intermittent says, Quindor, I get the joy of designing something and then hooking it up and it actually doing something first time. Yep. But no, cable tie, I do not have the pump connected to the water cannon. And even if I did, I think I'd have trouble sourcing the 50 litres of water a second that it would take to feed into it. Yeah, that's a lot of water. If you've got a big drum of water with a whole lot of stuff in it, it'd be empty in like 2 seconds. Like start the pump, it's gone. So, yes. All right. Cable tie says, woot, ship it. Yep. I would have said that when it compiled. Who cares about uploading it and running it on the target board? It compiles, ship it. So all this success has kind of made me pause for a moment. It's left me wondering what to do next. I'm doing a quick mental retake of what is going on with this thing. The main board is working, power is working, CAN bus is working. What we do not have working is the MCP. What we have not checked are the relay outputs and the optocoupler inputs, both of which rely on the MCP. So if that's not working, we can't get those working. So I've got to fix that first. What I have also not checked is the e-stop input, the limit switch input. The limit switch also relies on the MCP, and the stepper motor output drivers. Now, one thing that I have not even checked, this would be really super embarrassing. So if this is not right, I haven't even checked this yet. Let's see if I got the footprint right for the stepper driver modules. I'm just going to turn off the bench power supply for that water cannon. Move that out of the way. And what am I looking for? I've got a box up here called motion controllers, and it's got a whole bunch of things like smoothie boards, all the stuff that I use for CNC and laser cutter and 3D printer projects and things. And I've got a whole lot of I've got motor driver modules and lots of assorted stuff. here we go. So here is one out of the box that I failed to prepare earlier. Now, this is the question. Does that fit onto that footprint? Here's the big moment. I haven't looked at which way around it goes yet. Oh, it looks like it does. Amazing. You can see that the capacitors, so I've got these big bulk decoupling caps connected straight across the power supply that goes to the motors. So this is the motor voltage, and they stick up just slightly ahead of, like above the header, but there is a bit of space under the module. So once this is plugged in, it should clear. Now, which way around is it? Enable and V-mote there. And where is enable and V-mote on this? So ground is there, V-mote is there, it goes that way. Okay, so it plugs in like that. Very good. And it fits. So I can put two on there. Now, there is a whole secret aspect to this project that I have not mentioned anywhere yet. And just wondering if now is the time to reveal it. And it's kind of at the appropriate time because I'm just looking at whether these fit. So, okay, I'm going to reveal it. And then I think I'm going to wrap up the live stream after that. I'm just going to show you some bare PCBs, which I've got somewhere over here. These things, yes. These are bare PCBs that I ordered at the same time, and they fit the same footprint as this. I haven't assembled any of this, I haven't tested any of it. This is just brand new. I've designed two little boards that fit onto that same footprint for doing slightly unusual things with this. So, which one is which? I don't know. Okay. This one is pretty straightforward. This is just an H-bridge. Like it's a, what is this? A DRV8871, I think. I can't remember. It's just a little H-bridge chip that goes on there. The idea is that this is really optimized for driving DC motors. So it's got so what it does is it uses the step and direction pins to control the H-bridge. And yeah, so there are already modules around. Like this is a stepper motor module, which is for driving a what is it, a 4-wire, so it's like a bipolar stepper. And this is just, the idea with this was that it would be a simple way to connect a DC motor. Just use two of the wires here, not all four, you just use two, connect a DC motor, and you can treat it like a normal H-bridge sort of thing and just drive it with a regular H-bridge driver. That's not too exciting, and you can do that with other modules as well. I don't even know why I designed that. I kind of did. Okay, so this one is slightly different. This is just an N MOSFET with flyback diode footprint there and bias resistors. And the idea with this one is that you can use this and two of the connections on this header. So once again, not all of four of them, just use two of them to drive a large solenoid and use the, what is it, the step pin? I think it's only the step pin on this that's used. So basically you drive the step pin high and it turns on the output, and it's got the flyback protection on there because if you're driving a big solenoid, when you turn it off, you get the field collapsing, you get the reverse voltage spike. So it protects it against that. Now the reason I did this is so that what I could do is load this board up. I can put a regular stepper driver in one location, and I can put this high current N MOSFET thing. So this would be, what's the part number? I can't remember, but this is like it's a 20 amp rated MOSFET, like 20 amp, 60 volts. so it can switch a pretty chunky load. Not that you'd want to pass 20 amps or 30 amps through these pins, but still, the idea is this is for my friend Steve's bend press. So what he's building at the moment is a pretty big sheet metal bender, and he wants to have a backstop on it that is computer controlled. And the idea is that what we'll do is have a stepper motor with a ball screw that will drive the backstop. So what you do is you dial up how far you want the backstop to be, and it will move to that position, and then you can put your material into the sheet bender. It'll butt up against the backstop, and then you bring the machine down so that it clamps on it, and then before the actual folding happens, the backstop moves out of the way. And the reason for that is that you don't want it interfering with the material as the bend is happening. And so what this design is based on is having the ball screw drive the backstop for the sheet bender, and then there is a disc brake. It's like a disc brake on a push bike. You've got or on a a motorbike or something that's smaller than that. So on like a mountain bike with disc brakes, there's typically a disc that's like this big, and then there is a clamp, like calipers that clamp on it from both sides with two pads. So what Steve is doing is building it with the ball screw that drives the backstop and moves it to the correct position. Then the disc brake engages and it locks it in position, and that takes the strain off the ball screw. So then when the material is loaded and it hits the backstop can't move because the disc brake is clamping its location and there's no load on the ball screw. Then when you want to move it again, you release the disc brake and then run the stepper motor and then move the backstop out of the way. So that's what this combination is for. What he wants on his sheet bender is to have this as a little touchscreen interface. So if he wanted the backstop to come up to say 273 millimeters, he can go 273, go, and then the backstop will move up. It'll apply the disc brake, and then you can bring the clamp down on the material, and then it releases the disc brake and then moves the backstop out of the way again, and do all of that automatically. So that's why we wanted a combination of controlling a stepper motor plus a big solenoid, which is what will control the brake. So this little board is what will switch the solenoid for the disc brakes. Anyway, kind of niche, very specific, but yeah, these boards it cost what, $3 or something to have some of these boards made, so I thought I would do it. All right. Next step beyond this is testing the stepper motor driver, but I think I'm going to pause for tonight. I think I'm done with this because I started first thing this morning and I'm still going. I will instead take a moment to check out the chat. What is the time? 9:50. So I've been going for nearly... Is that right? Have I been going for nearly 2 hours? How does that happen? Okay. Where am I? Yeah, Gerald said, I think you mentioned this in the design phase. This sounds familiar. Yeah, I probably did mention it in the design phase. So Dodgy says, I thought the backstop was going to control the angle, but it sounds more like it's controlling the material length. Good point. I may be wrong about my understanding of this. My understanding was that it is controlling the material length, because one of the critical things when you're doing sheet bending is getting the bend at the correct location, because as the bend happens, it tends to pull the material in one direction or the other. And so you typically need to do a couple of trial runs. So what you would do is, if you want your bend, the actual bend to be centered on a certain distance from the edge of the material, what you do is you get it as close as you can, like what you think it's going to be. You set the backstop to that position, you run your bend, and then you measure it, and you might discover that it is 2.3 millimeters too far in one direction. So you adjust the position of your backstop, run it again, and then your bend should be spot on. And at that point, you're calibrated. So I think the idea with this is that he wants to be able to dial up a position on the backstop and have it, and put the material in, run the bend, and then have the backstop move out of the way. And then when he puts the material in next time, it comes back to the exact same place again. So he's got reproducible distance on the backstop. I think that is the way it is set up. But how far you bend as well, on like when you're bending sheet metal, that is also a critical thing to control. So you've got, if you've got a flat piece of metal and you want to bend it like that, you want to control the distance from the edge at which the bend occurs, and you want to control the angle, like how far it is bent. And also you want to control things like the radius. So because the radius can be critical depending on the material, hardness, and all sorts of things. Yeah. Is it a manual bender or powered? I don't know, Dodgy. I don't know. There's so much gear in Steve's factory that, like, he's already got sheet benders. And in fact, just a couple of days ago, he was telling me, so I'm just wondering how much to get into this. His childhood, he grew up on a farm in like a really remote location in Victoria, right over sort of near the South Australian border. And his dad had a business making irrigation systems for farms, like really big. You know those irrigation systems where they have a gantry that's like 60 meters long and it's got sprayers all the way along it, and it automatically like drives down the rows of stuff in a paddock? That's the sort of stuff they used to build. And from the time he was a little kid, he was working in his dad's workshop. But this workshop, the way he described it was every single thing in the workshop, the tools and the materials, needed a crane to move it, and if you made a mistake, it'd kill you. So he had a sheet, he had a bend press in this workshop. What was the number? It was some ridiculous length. It would bend a sheet of metal like up to 40 feet long or something, like a 40-foot long bend, because they use those on these enormous irrigation gantries. And so, yeah, and you know, things like CNC machines that weigh 15 tons and stuff like that. Yeah, so in his current factory, he's got something like 12 machines, you know, lathes and CNC machines and that sort of thing. He already has he's gotten several sheet benders already, and I actually don't know what his plan is for this one. All I know is what he's told me about the backstop system. And it's because I was talking to him about I actually showed him my design for the PCB conveyor and the controller for it, and he looked at the controller and went, I could use that on the backstop of my sheet bender. So that's where all of that came out. Yeah, okay. Yeah, so as Doji says, because if it is manual, the fold angle would be nearly as important as the length, if not more so. Yeah. Yeah, all of that stuff is beyond me. Things like metal fabrication, I admire it. The things that he can fabricate are amazing. In fact, last week, he showed me a pedal box for the electric car that he's building. And so he hand fabricated. When I say hand fabricated, obviously he used tools. He built the pedal box for this electric car that he's designing, and it is a work of art. It's the sort of thing that you could take this pedal box and put it in a glass box and put it in like an art gallery or something, and you would go and stand and stare at it. It was absolutely amazing. the shaft of, like, it's got the pedal plates that you put your foot against are mounted on oval steel, and the oval was, he made it out of round section and then squashed it, but he squashed it using tools that prevented any like flats forming, and molded it to the correct angle. So it's got this oval shaped steel that it just looks amazing. Anyway, and the welds and things are just incredible. It's a work of art. So yeah, I have great admiration for people that can fabricate physical stuff like that, and it's really, really impressive. I can't do it. Dodgy says, so like a mandrel bend. Not quite. So yeah, a mandrel bend, I know what you mean by that. But no, this was taking a round section and partly flattening it into an oval shape. So the oval shape, and I don't think there was even any reason for it. He did it just because it makes it look awesome, rather than having just a round section tube or a square section tube. He could have made this pedal box just with like a square section steel tube, cut it off with the angle grinder, welded the plate on, and you're done. But he didn't. He's treated this thing like a work of art, and it just looks amazing. Yeah, I need to get some of his stuff. Yeah, so that was last week. When he showed me that, and at the same time he had the lower control arm from the GTR that Jim Richards crashed at Bathurst, the one where he was driving along with the front left wheel at like a 45-degree angle, and Steve kept the lower control arm out of it, so he's still got that all these years later. How long was that? That must be close to 30 years ago that crash happened, and he's still got the lower control arm from that Nissan GTR. 1992 Bathurst, that's it. Yep. Right. I really want to take a camera sometime to Steve's place and show you some stuff, because it is really, really cool. And hopefully sometime we will get to see his electric car as well, which is currently like a rolling chassis. There's no body on it. And what he's in the process of doing, like the next thing he's doing, is making his own electric motors. He's kind of like that. I would have just gone and bought off-the-shelf electric motors, but he has designed his own electric motors, including like the coil windings and the magnet system and everything, and he's fabricating the motors from scratch, like winding the coils, because he wants to maximize the performance of the motors. They're hub motors, and he's using motorcycle rims on the car. So it's a very lightweight car, and he's used like large diameter motorcycle rims so that it's got low rolling resistance, and he can, with the extra diameter inside the rim, it means he can get more torque out of the motor by taking the motor right out to the edge of the rim. Dodgy. Yes, the classic quote from John Bow. All right. Outside the box says, sounds like a part from the shelf, offerings to the god of speed. Yes. Offerings to the god of speed. The broken parts, the exploded piston heads and that sort of thing. Yeah. So I'm still talking. What am I doing? Right. I'm gonna go because it's now 10 o'clock here, and I'm gonna have to get some sleep, get up in the morning, do it all over again. I've got some client work I have to do in the morning, so I need to keep going. But it's been fun doing a bit of a short notice live stream. Maybe I should do some more evening live streams. Yeah, different times, because the Sunday morning Melbourne time doesn't suit large parts of the world. Alan says, going to have some lunch. Yes, you should do that. Okay, thank you everybody. Now before I go, I need to unlock my laptop because that is how I display the thanks for watching thing. So I am going to go and give my voice a rest. Thanks everybody, and I will talk to you really soon, and I've got to remember to turn off the soldering iron. All right, see ya.